Hi everyone, my name's Louisa, and in this video I'm just going to teach you the basic equation for the capacitance of a parallel plate capacitor, and I'm going to use it in a couple of simple examples. So I'm just going to introduce to you the formula that you can use to find the capacitance of a parallel plate capacitor. That is a capacitor that looks like this. There is a way to derive this mathematically, but it's a little bit complicated, so I'm not going to get into it here. However, if you're interested in it, there's many websites where you can see the derivation. So, the capacitance for a parallel plate capacitor, which I'm going to indicate with this little parallel symbol here, is pretty simple. It's going to be epsilon naught times A, representing the area of the plates, divided by D, which is the distance. So just to clarify again, A in this formula represents the surface area of one plate, and D is equal to the distance between the plates. Now you may be wondering what epsilon naught is, and it's really just a constant. The value of this constant is about 8.85 times 10 to the negative 12th power, and the units are farads per meter. Now a farad is a unit of capacitance, and we all know that a meter is a unit of distance. So the way this works out is pretty nice. We have in our units farads over meters, this is from epsilon naught, times area, which is meters squared, divided by distance, which is meters, and we end up with these will cancel, and we end up with just F, farads, which, like I said, is a unit of capacitance, which makes sense. That's what we expected to find here. So if we were looking at this capacitor and we wanted to find the capacitance, we'd simply multiply those factors the way that the formula tells us to. So we'd start with epsilon naught, and then we'd multiply it by the area, which is just going to be W times L, and then the whole thing is divided by the distance D between the two plates. So that would be the capacitance of this. Now it's interesting because you'll notice that this equation doesn't include the voltage across or the charge on each plate. What that tells us is that the capacitance of a capacitor is only dependent on the geometry. The only things here that can change are the area of the plates and the distance between them. Epsilon naught is never going to have a different value. In fact, the only case where we need to worry about there being anything other than epsilon naught is if we have a dielectric or a non-conductor inserted into the surface here. But that's something for another lecture. The important thing to get out of this one is that the capacitance of a parallel plate capacitor can be calculated by doing epsilon naught times the area of one plate divided by the distance between them. And that does not involve charge or voltage. It's only dependent on geometric properties.